Hello and welcome to EE233. I'm your instructor, Gregory Myers. This video, we're going to take a introductory look at for loops and focus on the syntax and some basic examples. This video is part of a larger series of videos under the fundamentals demo. And to begin with, this assumes that you have a copy of the for_loops_01 snips file, or if you want to take just a second to go ahead and do a screen capture of the code. So let's go ahead and get started. The first thing we want to do is we want to go ahead and copy our function prototype over into the list of function prototypes. And then we want to go ahead and copy this template here, including the comments, and append that somewhere toward the end of your fundamentals.c file. At this point, we no longer need the snips file, and we're going to focus just on implementing this particular demo. So to begin with, you'll notice that I have some code here in comments, if you would, that just basically outline the structure of a for loop, and we're going to break it into a couple of different parts. First, you'll notice here that I have some terms, or some expressions rather, inside the set of parentheses, and so we want to talk a little bit about how a for loop works. The idea here is that a for loop will allow for you to run a line of code or multiple lines of code 0 or more times. So the idea here is that anything within these curly braces or within this block of code will then be run 0 or more times. We'll come back to the 0 in just a second, but for the most part, you want to think of for loops as being able to run blocks of code or multiple lines of code many times, and specifically, or at least the intention is, a predictable number of times. Now, we'll have a little bit more of a discussion about when you would choose for loops in another video, but to begin with, what we want to do is we want to look at the three parts of this first part of the syntax here, specifically the initialization expression. And the idea here is this is the value where the loop starts. So basically what we want to do is we want to initialize the loop with a beginning value. The second step here, this loop repetition condition, can be thought of as a condition or an expression that must evaluate to a Boolean, or true or false. And the idea is that this loop condition is what controls when the for loop stops. So this right here controls when the loop stops. So the idea is that you can write then that expression or that condition in such a way that whenever a maximum value, for instance, is reached, the loop stops executing. The third part of the syntax is the update expression part, and that is just simply how you update the control variable or control condition. And so the idea is, let's say we're trying to start off our for loop at, let's say, the value 0, and we want to simply count up to the value 9. Well, if we want to count in whole numbers, then our update expression would be 1. So in other words, we'd increase the count by 1. Now, you're going to see that in C, there are many different ways to do this. So what we're going to do in this video is we're just going to simply focus on the simple example using integers and a simple example using doubles. And so you'll notice up here at the top of our function, I've included two temporary variables that I've declared, but not yet initialized. So the idea here is that we want to use this index variable to control a for loop, and then ultimately a little later on, we're going to use this current variable to control the for loop. Now, don't focus too much on the names of these variables. If anything, these are just maybe a suggestion, or even in some cases, you could argue best practice, at least in the example of the index variable, but there's nothing magic about these particular variables. Instead, they're just easy to recognize or useful when it comes to writing code. So to begin with, what I want to do here is I want to jump outside of my comments, and I want to start by following this template for the for loop. And you'll see here that I have for followed by parentheses, and then notice here that the initialization expression, the loop repetition condition, have semicolons, but the update expression does not. The other thing to notice real quickly is the curly braces. Now, when you have a single line statement or a single line of code, you don't necessarily need the curly braces. However, I encourage you to use them all the time, as there is no detrimental effects to using them. If anything, it just helps your code look cleaner. So to begin with here, we'll have our for statement, and then inside our initialization expression, we're going to start off with the example that I mentioned earlier of counting from 0 to 9. And so what we want to do here is we want to utilize our index variable. We want to initialize it to 0. We want to count up to 9. And in this particular example, we're going to include 9. So what we want to do is have less than or equal to 9 as the loop repetition condition. In other words, that's going to control when the loop stops. And then the third part of the syntax then is the update expression. And basically that controls how we increment the index variable. Or, as you're going to see later, we can also decrement it. But basically how the update variable changes. So in this particular case, I want to count by 1. So I simply say index is equal to index plus 1. Now, we're going to see some shorthand notation in a little while also, but for right now, I'm going to use the more verbose syntax here. We follow this up with a set of curly braces, and you'll notice that NetBeans auto matches our curly braces. Now we're set to write several lines of code, ideally. Okay, so basically, we put our lines of code here. For this particular example, we're not going to do a whole lot. And as a matter of fact, what I'd like to do for this example is, for each one of these, is just simply create a nice looking table that shows us not only how the index, in this case, increments, but also maybe the results of a simple operation. So in this particular case, what I'm going to do is I'm simply going to add at the beginning and at the end of this for loop a nice border. Nothing fancy, just a printf with some equal signs. And I'm also going to do the same thing at the end of the for loop. And then inside, what I want to do is I want to leverage that index variable. And I'd like to simply print out the value of the index. So I'm going to use a %d. And then at this point, then I'm just going to utilize that %d for some sort of operation. So a good example here might just simply be doing something like multiples of 2. So what I'm going to do is I'm going to put as a second placeholder another %d followed by a new line. And for the first placeholder, I'm going to simply just specify the index. And for the second placeholder, I'm just going to do 2 times the index. Once again, nothing very complicated at all. Now, to further improve the aesthetics here, what we can do is we can also take just a second in this particular case to have another printf, and at the top here, maybe have an index and some value. Now that's obviously not required. It's just helps make this look a little more appealing. Now, before we go too much further, let's go ahead and build it. And while this is building, let's think real quick about what we would expect to see. So the first time the loop runs, the index is going to be 0, and 2 times 0 is going to simply be 0. Next time the loop runs, the index should be 1 because we're incrementing the index each time we loop. And we should see 1, and then 2 times 1 is 2. The next time the loop runs, the value for the index should be 2. 2 times 2 is 4, and so on all the way through until the index is equal to 9. So we would expect to see %d. This %d would result in 9 times 2 times 9 is, of course, 18. And then when the loop attempts to run one last time, or when we add 1 to 9 to get 10, then this condition right here would evaluate to false and then kick us out of the for loop. So we've once again written our prototype, or included our prototype. We've written our function. But now what we need to do is we need to go up to our main, and we need to include it as an option in our ever-growing bank of switch statements. So to begin with here, what we're going to do are either else-if statements. So in the switches, or the command line switches, we're triaging with our else-if, else-if. So in this case, what we want to do is an else-if, and we have a single condition this time around that we're going to evaluate. That's just going to be utilizing string compare I. We're going to compare the value of argv square brackets 1. If you recall, that's the switch that follows the executable name on the command line. And in this case, to match up with the name of the function that we've just written, it's going to be for underscore loop underscore 01. And if we have a match there, then we assume that the user wants to call our for loops demo. So notice, by the way, it's for underscore loops. So let me add my S there. And so this calls our first for loop demo. And at this point, the only thing left to do is then to update our help. So just take just a second to go about doing this. Once again, we can keep the documentation pretty simple. So we're just going to call this for loops underscore 01. And for right now, we're just going to say call for loops underscore 01. Once again, we're going to build it. We're going to come out to the command line. It's very important that you remember where your project is located, because what we want to do is we want to CD over to that location. So in my cases, it's documents, courses, EE233, projects, and then our fundamentals demo. You'll then notice the distribution folder, debug, and min.gw. And there's our fundamentals demo.exe. And if we run it without any switches, we should just simply get our help. And sure enough, it gives us our help. And so what we want to do is we want to call it with our for loops 01 switch. And you can see we've almost got the table lined up. Doesn't look too bad for a first pass, but you'll see in the first column is the index, and in the second column is the value. In this case, we've simply multiplied 2 times the index. Notice here that this runs for a total of 10 times. We didn't keep track of that necessarily, but we can tell from the table what the values of the index are before we terminate the for loop. So we said earlier in the video, when we added 1 to 9, and then we compared our 9 to, or rather our 10 to our 9, then we exited out of our for loop. Now, let's take just a second to improve the aesthetics a little bit. I'm going to move my second column over ever so slightly. And just clean this up just a little bit, build it one more time. And there you go. Doesn't look too bad. Once again, we can continue to improve on that as we see fit. And then what we'll do later on is we'll actually add a title to this example once we get some of the others working, or a little bit of documentation. But to begin with here, this first example simply allows for us to count from 0 to 9 in increments of +1. Now, what if we didn't want to count up, but rather we wanted to count down? So what I'd like to do is I'd like to just go ahead and borrow some of our print statements and make another table first. And then inside of this table, I'd like to write a for loop with the intention of counting from 9 back down to 0. So you can probably guess what the difference is going to be. Well, first off, we're going to initialize the index at 9. We are going to terminate the loop when the index reaches 0. So in other words, if we're counting down from 9, we will continue the for loop under the condition that our index is greater than or equal to 0. Once again, as long as the expression evaluates to either a true or a false, the condition can be used. And then for our incrementing condition, or in this case, a decrement, we would simply take the index value and we would subtract 1 from it. Notice once again the use of the semicolons after the first two parts in the for loop syntax and the absence in the third part, followed by the curly braces. Once again, we would ideally have several lines of code here. In this case, our goal is just simply to print out the value, or excuse me, rather the index followed by the value of some operation. And so what I'm going to do is, once again, I'm going to use my printf followed by a %d, and I'm going to roughly line this up with the earlier example, followed by another %d. And for the first placeholder, I'm going to put in my index. And then for my second one, simply 2 times my index. Basically the same code from earlier, with the distinction being that I am starting this loop at 9. I'm going to end the loop at 0, and I'm going to decrement the index. Once again, go ahead and build it. Let's come out here to our command line, go and run it. And now you see that essentially I am reversing the operation from the first example. So in this case, I'm starting out at 9 and I'm going down to 0, and my values go from 18 down to 0. This value side of this table is really just to demonstrate then what you could use that index for. Now, are we limited to integers? And the answer is no, absolutely not. As a matter of fact, what I'd like to do now is I'd like to once again borrow our nice little table structure here. And in this case, what I'd like to do is I would like to build a for loop using a double. And so as you can guess, we have our current variable up here. I could have had basically an index as an integer and also maybe had a second variable called index double. But the idea here is I want us to sort of see then that we can have an integer as well as a double for the driver or for the control in a for loop. As a matter of fact, you're going to see that in C, you can actually use some of other data types as well. So to begin with, what we want to do is just like in the earlier example, we want to initialize our loop variable. In this case, it's going to be current. So for current equal to, I'm going to start off with 0.0, and I'm going to keep this very similar to the integer example. But in this case, what I need to do is I need to continue while current is less than or equal to 9.0. And then lastly, current equal to current plus 1.0. Once again, I'm keeping this all in terms of doubles. I'm not allowing for any sort of implicit conversions or anything like that. In this case, what I want to do is a slightly different operation. I'm going to do the %. Now, keep in mind, we're doubles here, so we can't just use %d. So I'm going to use %.d 2F for my format spec. I'm also going to roughly keep this lined up with the previous example. We might have to tweak it a little bit. And for the second value, I'm going to have %.2F as well, and followed by a new line. For the first value, I simply want to put in current. And then for the second value, I'm going to use the POW function. And in this case, I want to calculate powers of 2. So I'm going to use 2 as the base, and then current as the second parameter. Now, let's go ahead and build this one. Let's see how we did as far as aligning our tables. The idea here is that once again, it should start off at 0 and continue on to 9 for the index. And for the value then is going to be 1 and up to 512. Now, little minor detail here, we have index still listed in this table. This is technically the current value. We want to come back and revisit why we would call this index then in a later video. This is just meant to be sort of an introduction, if you would, to how for loops work. Before I leave you though with this video, I would like to point out that some of you may have already seen this syntax, that you can abbreviate or shorten this increment condition here, this increment code. And in this case, what you would do is you would simply say index plus plus. And what you're going to discover is that this is interchangeable with index equal to index plus 1. Likewise, with the index equal to index minus 1, there is a shorthand notation for that. And in this case, it's going to be index minus minus. And that allows for you to decrement. So in this case, it's going to be index equal to index minus 1. And then as an alternative, especially when you are dealing with the double data type, you can also, there's another alternative syntax, and that is you can simply say current plus equal to whatever that increment is. And that takes the current value and then it adds whatever that increment is to it. So this right here would be then interchangeable with current equal to current plus 1.0. And once again, either approach is fine. I would, however, at least in the beginning, encourage you to use this longhand notation because essentially it's a little more clear, a little more self-documenting. And also what you're going to discover is that not all languages support these abbreviated syntaxes, whereas most of them will support this longer notation. So as always, I hope you found this video useful, and thank you for watching.